Alright, good morning guys, this is Mr. McCloskey. Today I'm going to teach you to solve equations with variables on both sides. So in my first video I taught you how to solve simple two-step equations, and then in my second video I taught you how to solve a two-step equation including the distributive property where you distribute and then you solve the two-step equation. And last time I taught you how to solve an equation where you had to distribute and then combine like terms. Today we're getting rid of the combine like terms step, but we are adding in the variables on both sides step. And then in my next video we'll include everything. So as always, these questions that I'm about to do are going to be in the Google Classroom, that the join code will be in the description of this video, so you can follow along with that if you join the Google Classroom. And then I'll have some problems for you to practice along with these problems that I'm about to do. The best way to learn is to do these problems along with me and then practice those problems that I have for you. So number one, we have 3 and then in parentheses a 5y plus 6 is equal to 2, and then in parentheses 4y minus 5. So our first step is always to distribute. Whenever there are parentheses, you always take the number on the outside of the parentheses and you multiply it by both the things on the inside of the parentheses. So 3 times 5y is 15y. 3 times 6 is positive 18. And then you do the same thing on the right side of the equal sign. You take the 2 and you multiply it to the 4y and then negative 5. 2 times 4y is 8y. 2 times negative 5 is negative 10. Okay, now this is the new step, okay? Normally you would combine like terms here, but to be a like term they have to either both have a y or both not have a y and be on the same side of the equal sign, and that doesn't happen in this problem. So we have to, we get to skip that step for today, but we need to move the variable to one side of the equal sign. I always like to move my variables to the left side, but that's not necessary. You can move it to the right side, but I always move it to the left side. So you look at the number with the variable on the right side, it's a positive 8y. The way you cancel out a positive 8y is by subtracting 8y to both sides. It cancels out on the right side, and then you do 15 minus 8, which is 7y. The plus 18 drops. The negative 10 drops. And then you subtract 18 to both sides. That cancels, the 7y drops. Negative 10 minus 18 is negative 28. And then you divide by 7. So y is equal to negative 4. Okay, there's number one. We're going to do 6 problems together, I believe. Yep, 6 problems is what I have. All right, number 2. Draw my line through the equal sign. There's no parentheses on the left side, so all of that stuff on the left side is just going to drop for now. But on the right side we have parentheses, which means we have to distribute. So we take that negative 2 and we multiply it by negative 7n and positive 1. Negative 2 times negative 7n is positive 14n. Negative 2 times positive 1 is negative 2. And then we're back to that step where we have to move the variables to one side. So I always look at the right side. There's a positive 14n, so we subtract 14n. Subtract 14n. That cancels. 5 minus 14 is negative 9n. The plus 34 drops. The negative 2 drops. Now we need to add or subtract something. We subtract the 34 to both sides. That cancels, the negative 9 and drops. Negative 2 minus 34 is negative 36. And then we divide both sides by negative 9. Cancels, negative 36 divided by negative 9 is positive 4. So n is equal to positive 4. All right, number 3 is kind of different. It's a little bit of a shorter equation. Sometimes this happens, but there's still a variable on both sides. There's no parentheses, so we get to skip the distributing step. There's no like terms, so we get to skip that step. But there is a variable on both sides, so we need to move the variable to one side. Once again, I always like to look at the right side. There's a positive 7a, so we need to cancel out that positive 7a by subtracting 7a. 6 minus 7 is negative 1, so negative 1a. The negative 6 drops. So we have negative 1a is equal to negative 6. There's nothing to add or subtract, so we get to skip that step as well. But we do need to divide by negative 1, so we divide both sides by negative 1. Negative 6 divided by negative 1 is positive 6, so a is equal to positive 6. All right, so going down to number 4. With number 4, we have negative 10x minus 2 is equal to negative 8x minus 1. There's no parentheses, so we get to skip the distributing step. There is a variable on both sides, though. There's a negative 10x and a negative 8x. I always look at the variable on the right side, and I cancel that out. It's a negative 8x, so we have to add 8x to both sides. That cancels. Negative 10 plus 8 is negative 2x. The negative 2 drops. The negative 1 drops. And then we need to add or subtract something. The negative 2 on the left side is what we need to add or subtract. You cancel it out by adding 2. So that cancels. The negative 2x drops. Negative 1 plus 2 is positive 1. And then you divide both sides by negative 2. And if you want to write your answer as a decimal, it would be negative 0.5. If you want to leave it as a fraction, it would be negative 1 over 2. So either of those answers should be acceptable. All right, number 5. We have some parentheses again. Okay, so that means we need to distribute. This left side, there's no parentheses, so everything just drops. 3 minus 9x drops down, and then you do 3 times 1, and 3 times negative 3x. 3 times 1 is positive 3. 3 times negative 3x is negative 9x. Okay, now we need to move the variables to one side. I always look at the variable on the right side. It's a negative 9x, so we add 9x, add 9x. Cancels on the right side, and something weird happens here where the x's actually cancel out on both sides. Okay, when this happens, you drop the numbers down that are remaining, the 3 and the 3, and this is what's called a special case. Whenever the x's cancel on both sides, it's a special case because the x's cancel. Okay, this is a weird thing that happens sometimes. Whenever it's a special case and the x's cancel, that means your answer can either be infinite solution or no solution. Infinite with the infinity sign, it stands for infinite solution. Or it can be no solution with the no smoking sign. Okay, that means no solution. Okay, and the way you tell the difference is it's infinite solution when the numbers remaining are the same. So this one is infinite solution. So you just make that infinity sign like that. And that's because the numbers remaining, the 3 and the 3 that did not cancel out, are exactly the same. Okay, what this means is you could take any number in the world, you could take 1 or 1 million and substitute it in for x, and both sides of the equal sign would come out to be the same. Okay, so any number would work for substituting, to substitute in for x to make both sides equal to each other. So that means there are infinite solutions. Okay, no solution. If these numbers left were different, the answer would be no solution. And that would mean there would be no number that exists that you could put in, you could substitute in for x that would give you the same number on both sides of the equal sign. No number would exist, so that would be no solution. When the numbers remaining are the same, your answer is infinite solution. When the numbers remaining are different, your answer is no solution. All right, let's look at the last one, number 6 here. There's parentheses on the left side, so that means you distribute. 4 times negative 8 is negative 32x. 4 times 5 is positive 20. Everything on the right side just drops down because there's no parentheses over there. And then we got to move our variable to the left side. I look at the right side, there's a negative 32x over there, so I add 32x to both sides. That cancels, and what do you know? It also cancels on the left side as well, so that means that this is another special case whenever the x's cancel. And then you look at the numbers that are left to decide if your answer is infinite solution or no solution. The numbers left are 20 and negative 26. They are not the same. So the numbers remaining are not the same, which means our answer is no solution. And once again, this means that there is no number that exists that you can substitute in for x that will give you the same number on both sides of the equal sign. Okay, so your answer is no solution. All right, once again, these problems that I just did, they are in the Google Classroom, and I also have 9 problems just like this for you to practice on your own. Okay, the best way to learn is to follow along with me as I do these problems and then practice the remaining problems. Okay, have a great day. Goodbye.